In this section, we're going to be looking at dividing a polynomial by a polynomial. As before, we can write this two different ways. And in fact, your textbook doesn't write it out this way, but it says divide, and then it gives you the fraction. We can't really do division here because, remember, we can't cancel, say, this x with this x because this plus sign is in the way. I'd have to be able to divide this x with this x and this 4, and 4 with this 4 and this 20 and this 9 and so on, and we can't do that. So our only recourse in a problem like this, whether it's given to us like this or like this, is to rewrite it like this and solve the problem by long division. It's not immediately obvious what I need to multiply by x plus 4 to get this trinomial. But as when I do long division with just numbers, I can estimate. Let me show you what I mean. If I were doing a long division problem like 28 into 5,762, I'd have to look at 28 and see how many times it went into 57, or at least as close as I could get. 1 times 28 is 28. 2 times 28 is 56. That's not quite 57, but it's as close as I can get without going over. So I estimate that it will go in twice, even though it won't go in exactly twice. Then I'll say 2 times 28 is 56, and subtract, and so on. Let's continue this problem, because there's something else I'd like to show you. When I do my subtraction and bring down the next number, I then can ask myself, how many times does 28 go into 16? Or what do I need to multiply by 28 to get 16? And the answer is that there isn't anything. So I'll put a placeholder 0 here to say that although I know my answer is going to be 200 and something, it's going to be 200 and something but no 10s and then some 1s. Since bringing down to 6 wasn't enough, I'll now also bring down the 2. And then I can ask, what do I need to multiply by 28 to get 162, or to get as close as I can? Turns out that's 6. And in fact, 6 times 28 is exactly 162. Subtracting, I get 0. So I have no remainder here. My answer is 206. Instead of that, what if I had asked you to divide 5,765 by 28? 28 still goes into 57 twice, and 2 times 28 is 56. And I subtract, and I bring down the 6, and 28 still doesn't go into 16. This time I'm going to bring down the 5. 28 goes into 165 6 times, and this time when I subtract, I have a remainder of 3. How do we write this answer? We write 206 and 3 over 28. You may remember seeing a long division answer also sometimes written this way, R3, or remainder 3. Let's point out here that the remainder is 3. The remainder is 3, not 3/28, just 3. Why is that important? Well, in WAMAP, sometimes questions like this will ask you to give the quotient and the remainder. And if that's the case, you need to make sure you get the right things in your answer boxes. The quotient is the piece you ended up with up here, so that would be 206. The remainder is 3. One more thing I'd like to point out here, and that is that I didn't talk about how many times 28 went into 5 because it was clear that it wasn't going to happen. I could have put a 0 there, but since it's a leading 0, I didn't need it. I did have to put a 0 here because with numbers, if there's not something else in that position, In other words, if I just wrote a 2 and then a 6, because of their positions, I would have to interpret that as 26. And that's very different from 206. With polynomials, it's not quite the same, but it's similar. The 2 in my answer is in the hundreds place. The 6 is in the ones place. So 28 goes into 5,200 and something times. We'll see that come up again over here when we first look at what our quotient might be. The position that our first term will go in is important. All right, enough arithmetic review. Let's get started on this problem. As with a number problem, I don't know how many times this whole thing goes into this whole thing, but I can estimate. What do I need to multiply by x to get x squared? The answer is x, and I could put that here, but remember I'm lining up my hundreds, tens, and ones, or my x squareds, x's, and ones. So since x times x is what it takes to get x squared, and x is the first term in my quotient, I'm going to line it up with the other x's in my problem. You'll see we'll get more down here as well. Now that I've decided that's what I'm going to use to multiply, I need to do the multiplication. But I'm not just multiplying it by x. I'm multiplying this x by the entire polynomial, by the entire binomial x plus 4. When I multiply x times x plus 4, I'm going to get an answer that I'll write here. What I end up writing in that line is the result of this multiplication. X times x plus 4 is x times x plus x times 4. So that's what I need to write here, x squared plus 4x. If you need to, you can do this work on scratch paper, but you don't have to write this out to be considered having shown your work. You can just think x times x and x times 4. In fact, let's write it out that way. X times x is x squared, and x times 4 is 4x. Now that I know what's on that line, the next step is to subtract. And this is where it becomes very important to think of subtraction as changing the signs and adding. It's not so critical with this problem, but with some it will be more important. Here I could just have thought x squared minus x squared is 0, and 9x minus 4x is 5x. We'll do one in a minute, where it's not quite so obvious. Once I've done my subtraction, or changed the signs and added, the next step is to bring down the next term, plus 20, and start all over again. Estimate what I need to multiply by x to get 5x. What times x is 5x? 5. Now that I've decided that 5 is what I need to multiply by x plus 4, I need to do that multiplication. 5 times x is 5x, and 5 times 4 is 20. Change the signs and add, and we get 0 plus 0, so there's no remainder. My answer is just x plus 5. With a problem like this, you can check your answer by multiplying x plus 5 times x plus 4, and you'll get this. X plus 5 times x plus 4 is x squared plus 4x plus 5x plus 20. Combining like terms, I get x squared plus 9x plus 20. This product matches my original question. That means that this whole thing, x plus 5, is what I need to multiply by this whole thing, x plus 4, to get the original question. My quotient in this case is x plus 5. My remainder is 0. Here's our next problem. Remember that a division problem involving polynomials might be presented this way, or it might be presented this way. In either case, because we're dividing a polynomial by a polynomial, we really have no choice but to rewrite the problem x squared minus 5x plus 8 divided by x minus 3. Now that it's in that form, I can start working. What do I need to multiply by x to get x squared? The answer to that is x, because x times x is x squared. But that's not enough. Once I've chosen this, I need to multiply it by all of this. X times x is x squared, but x times negative 3 is negative 3x. Now I need to change the signs and add. 0 minus 2x. Negative 5x plus 3x is negative 2x. The next step is to bring down the next term. And then I get to start over. What do I need to multiply by x to get negative 2x? Well, that would be negative 2. The 2 times the x is going to give me the 2x. But the negative here times positive is going to give me the negative product. Now that I've chosen negative 2, I need to multiply it by this polynomial, by this binomial. Negative 2 times x is negative 2x. Negative 2 times negative 3 is positive 6. Change the signs and add. Negative 2x plus 2x is 0. 8 plus negative 6 is 2. I would bring down another term, but I don't have one. That means I'm finished. So how do I write my answer? The quotient is x minus 2, and there's a remainder of 2. So I can write my answer like this. To enter this in WAMAP, make sure you put your denominator in parentheses. Some WAMAP questions will ask you, not for this format of the answer, but what's the quotient and what's the remainder? The quotient here is x minus 2. That's what we got along the top of the problem. It's the thing we determined we needed to multiply by x minus 3 to get as close as possible to x squared minus 5x plus 8. We had a little left over, and that's our remainder. The remainder is 2, not 2 over x minus 3. Here's another one. Recognizing that the first thing we need to do is rewrite the problem in the form of a long division question. Then we can start approximating. What do I need to multiply by 2x to get 6x squared? Well, 3 times 2 will give me 6, and x times x will give me x squared. But I can't stop there. I'm not multiplying 3x by 2x. I'm multiplying it by 2x minus 5. 3x times 2x is 6x squared, and 3x times negative 5 is negative 15x. Change the signs and add. Adding these together gives me 0. Adding these together, negative 11x plus 15x gives me 4x. Then I can bring down the next term and start over. What do I need to multiply by 2x to get 4x? 2. 2 times 2x is 4x, and 2 times negative 5 is negative 10. There's no sign here, and it looks like it should be negative, but it's not. If I put a negative here, then I'm saying negative 2 times 2, and that would be negative 4x. I'm trying to build 4x. So I need a positive to multiply by this positive to get this positive. This needs to be plus. A positive times a positive is a positive. Once I know positive 2 is the number I'm going to use, I need to use it on both pieces here. 2 times 2x is 4x, 2 times negative 5 is negative 10. Then I can change the signs and add. These always add up to 0. Have you noticed? Negative 14 plus 10 is negative 4. There's nothing else to bring down, so my final answer is 3x plus 2, and the remainder, negative 4, over the divisor, 2x minus 5. Since addition of a negative can be written as subtraction, here's another way to write this answer. 3x plus 2 minus 4 over 2x minus 5. This is, in fact, slightly better form, but I'll take either. What's important is that you recognize that the remainder is negative 4 and place it accordingly. Remember, too, that if you're asked for the quotient, the answer to that part is the 3x plus 2. If you're asked for the remainder, the answer is negative 4. Just negative 4. Example 4 in your textbook looks like this. We're not actually going to address problems like this in this class. It doesn't look terribly different, but it turns out that since there's no x squared term here, you run into problems when you're doing long division. It can still be done. If I rewrote this problem not as 2x cubed minus 3x plus 2, but 2x cubed plus 0x squared minus 3x plus 2, and then divided that by x minus 5, I wouldn't have any problems at all. I'm not going to bother taking this one any further because I'm not going to hold you responsible for problems like this. You won't see them on the exam, and you won't see them in WAMAP. You will see them later in your career, but we're not going to address them here. Another type of problem that your textbook addresses that we're not going to talk about here is problems like this one. It seems obvious already that there's something different about this problem because there are 4 terms in the numerator, and the highest power, the degree of the polynomial, is 3. And so far we've only dealt with 3 terms in the numerator where the highest power is 2. But that's not my concern. What do you do if you have a denominator that's more than just a binomial? Again, we're not going to address problems like this quarter, but I want you to see that it is possible to do a problem like this using the same techniques. Very quickly, just so that I can say I've shown you, I'll rewrite this problem in long division form and work it out for you. Now, I'm not going to have room to do that here, so I'm going to give myself some working space. Okay, let's get started. What do I need to multiply by 2x squared to get 2x cubed? Well, it turns out it's just x, because x times 2x squared is 2x cubed. But I'm not done. I'm not just multiplying by the first term. I'm multiplying by the whole polynomial. X times 2x squared is 2x cubed. X times negative 3x is negative 3x squared. And x times positive 2 is 2x. Subtract, which means change all the signs, and add. These add up to 0. Here I'll get negative 6x squared plus 9x. Notice that my x squared terms all line up, and my x terms all line up, even this one up here. Now I can bring down the next term and start over. What do I need to multiply by 2x squared to get negative 6x squared? Answer, negative 3. The negative 3 times positive 2 gives me the negative 6 that I need. Negative 3 times 2x squared is negative 6x squared. But remember, I have to multiply not just by that term, but by these other two terms as well. Negative 3 times negative 3x is positive 9x. And negative 3 times positive 2 is negative 6. Change the signs and add, and I end up with no remainder. My answer is just x minus 3. X minus 3 times 2x squared minus 3x plus 2 equals 2x cubed minus 9x squared plus 11x minus 6. If you don't believe me, try distribution on this, and you'll get this answer. As I said, this was just a demonstration. You won't see problems like this quarter. Dividing a polynomial by a polynomial, or as far as we're going to take it, dividing a polynomial by a binomial, is a short section in the textbook, and there aren't that many problems to work. But my experience has shown me that students struggle with this section. The best way to approach this section, after you've read examples 2 and 3, are to try as many simple problems as you can. Do all of the odd questions that I suggested, 1 through 23 odd. Start with the most basic ones, and even if it feels like they're too easy, keep at it. It won't really take you that long to do them, and you'll find that just a sheer rote practice really will serve you well. As with any textbook, the problems naturally get harder as you go along. But even if you haven't done it for any other section, the paper and pencil exercises for this topic really are the best approach to coming to grips with the ideas in this section.